So for this month's Swarf and Chips, you're going to come on a journey with me. This show is all about one thing. How do you get more out of your vertical machining centre?
Welcome to our Swarf, the first of our monthly shows that pinpoints topics, solves issues and gives greater awareness of manufacturing solutions. Now, if you visit our swarfandchips.tv, you'll be able to see the lineup of subjects coming to you in the coming months. Now, it's very important to note that this isn't a replacement for our weekly show. In fact, it's far from it. This is a series of bonus shows that go deep into the solutions to your engineering problems. And today, it's vertical machining centre efficiency. So my question to you is, to put your guesses below, how efficient do you think the average VMC machining is? So how efficient do you think it is? You've got your choices here, so 32%, 42%, 52% or 62%. And before you answer, just to clarify, Paul, what do we mean by machine efficiency?
Well, basically what we're talking about here is the uptime. So it's how long that spindle is actually cutting for and running and eliminating downtime.
So coming up, we break this down into the following topics. Now you'll see the timestamps next to each feature, so feel free to skip to the area of interest, but don't go anywhere yet, as before we head into section 1, cutting tools and tooling, I got Gio and Paul to do an elevator pitch for the subject for those that don't know what a VMC is.
Oh, so what is a vertical machining centre? Well, it's normally a three-axis machine where you've got an X, Y and a Z. It's housed in like a perimeter guarding so that you don't have swarf sort of flying out and coolant and all the rest of it. It's also got a tool changer integrated into the machine in order to improve productivity, and it's controlled by either normally a Fanuc or a Siemens or a Heidenhain or even a third-party control. That generally tends to make up what I'd call a VMC.
What is a VMC? A VMC is a machine tool that makes things. It's referred to by many as a mother machine. It's got a Z-axis, an X-axis and a Y-axis and a spindle that rotates. The components stay stationary on the bed of the machine tool. You can program it with a programming language, and there's several that you can choose from. And watch this program to find out how you can make it more efficient.
So Joe, in this section we're going to talk about how you can improve efficiency by using certain cutting tool strategies and products. Mm-hmm. Maybe let's look at parts like we've got here and talk about the ways of doing more on a component with less tools, because that's really what it's about, isn't it?
It can be. There are times to use more tools to get cycle times down and things like that, but as we look at automating processes now, if you're retrofitting a robot to a machine, often you don't have enough tools in the machine, because what you don't want to do is automate a process but then have to change your tool orders every operation. So by using tools that are universal can then reduce operations and reduce your inventory, and the amount of tools you need on a particular job can only be advantageous.
But is it a good argument to say that those particular products won't be as good at the individual tasks as maybe a dedicated tool?
No, not always. Certainly if you look at solid end mills, years gone by you'd use a 3-flute for pocketing, you'd use a multi-flute for profiling, maybe a 3 or 4 flute for slotting. Whereas now really there's some pretty good tools at doing everything out there. Okay, aluminium, if you're doing aluminium, ideally you'd use aluminium tooling, but take that out of the scenario, there's some pretty good all-round tools now.
Okay, let's look at what we've got here, because these are some good examples, aren't they? This is obviously thread milling.
Yeah, so this here, this is a gluing tool, this one. So that actually, it's a drill mill, as I call them. They've all got their fancy names, but essentially that's called a drifter, I think gluing call it. But
well, let's keep up with how the screen's moving. We'll come back to that.
Okay, so this is the gluing diver. So with this, you can see here it's slotting down at various angles. It goes to 45, then it actually drills. And you can drill and open up the pocket with that tool. It's good for profiling, it's good for slotting. So you can see this can replace 2 or 3 separate tools.
And can this, is it capable of cutting steels as well?
Yeah, so this is steel we're seeing here. I've seen it in heat resistant alloys also. Clearly you're not gonna, use these types of strategies and data, but it's a good all-round tool for sure.
And isn't it going to wear quite quickly though? When you look at the speed that's...
No, you'd be amazed. You'd think that, wouldn't you? But that's what these tools are designed to do. So quite the opposite.
Okay, next one, we're moving on here. This is quite interesting because I remember when I used to be machining the big casings on the diesel engines, I used to have to do chamfers on the bottom and on the top, and there were always different tools.
Yeah, so this is basically a drill. It chamfers top and bottom as well. The chamfer's actuated, so you do the top, then it goes back in, retracts, and you go to the bottom, it comes out again, and you do the bottom chamfer.
And how does that work? What's...
Well, that one I believe is driven by coolant. The through coolant puts pressure and it pushes out the chamfer tool.
And we're seeing here again another example of opening up a thread.
Yeah, so that's been sectioned just for the video essentially. But again, this is a Vargas tool. So that drills, threads and chamfers all with one tool. So you can see, again, if you carousel, if you haven't got enough positions for that and you don't want a dedicated chamfer tool or a drill even, that does the job great. Because
I'm going back and used to have a drill, you have to have an M6 tap, an M8 tap, an M12 tap, but now all of that can be done with one tool. So therefore, maybe the tool carousel, albeit it's important, but if you focus in this area, you can achieve great things with independent products or products.
That thread mill will be for a particular pitch, but you can do any sort of diameter as long as that pitch is the same. So yeah.
Looking at this part here, would you say then that with all the machining on here, you could, minimise the amount of tools that you use? And if you did, would it affect the cycle time? If you were trying to use one tool to fit all?
Yeah, so that one was done at Fanuc, wasn't it? A live we did, and from memory, probably 6 or 7 tools on there. You could do that probably definitely with 2, in theory. 2 tools. You could do a universal end mill, aluminium geometry to do all the roughing and the pocketing. And yeah, the threaded holes could be done using one of these tools we've just seen on the screen, which drills, threads and chamfers.
Right, so section 2, work holding. Gio, it's your favourite topic. Firstly, what are the problems in this area in 2 minutes? Go.
I'll try my best in 2 minutes, Lindsay. Work holding is probably one of the main aspects in which you can increase efficiency on a VMC for sure. But I think one of the biggest problems is that people don't even know that they've got a problem. And if they don't know, they don't know. You've got different volumes of work that you can put through a VMC. So some people will say, if you're doing low volume work, why do I need to increase my efficiency? Because I'm just doing one day, I might do another day.
Mm-hmm. But I had someone say that the other day.
And that is a big argument, and to a certain degree there is an element of truth to that, dependent on the kind of work that they do. Yeah. However, whether you're doing lower volume work or higher volume work, you can still increase the efficiencies of your VMC through work holding and getting the best work holding on your machine tool. Now, one of the biggest aspects of this, in my opinion, or the biggest pain point would be that you're not palletizing your VMC, so you're doing all of your setting in the machine tool, and if you're doing that, the spindle is not turning. Yeah. So by palletization and universal datum points within the machine tool, basically what you get there is that you can do all of your setting outside the machine tool, and then when you load the machine tool, the datums are already set. That's absolutely massive, whether you're doing low volume or high volume work. Another big pain point in work holding is if you're using old technology and you're not holding the part securely, you get vibration, and then you can't run the machine tool to its full capability, so you've got to reduce speeds. You don't get the best tool life longevity, so again, this is very inefficient. Also, with the palletization and moving back to that, another big point, this is probably going into different areas, but the work holding, you can automate it. So if you're looking to run 24/7, this is through work holding, and it's something that you should seriously consider. And I think that's about it for pain points, Lindsay.
Yeah.
I've got nothing left to say.
You've got nothing left to say, but we've gone well over 2 minutes.
and he's delivered all of it. I think the points he makes are so correct. I think the more you see the guy or the lady in the machine taking parts out, clocking things up, they are what you need to eliminate. So any work holding solution that you can add to that.
Right, okay. So now for some more solutions, and here's an example of what you can get from your VMC using creative work holding.
Chloe, perfect example here at meal turn of how you can present multiple components to the spindle, and not the same components either.
No, definitely not. So as you can see, we've got 2 setups in the vise, so that's used for the VMC. We've also got 2 chucks on there, so we can hold cylindrical material, not just blocks of metal. We've also got a 4th axis unit on there, so you're utilising your VMC while adding an extra axis on there.
Now, when moving from one component to the other, how do you do that with the datum shifts? Can you explain to our audience how you program that?
Yeah, definitely. So one part will have a G54, and then the next one will be G55, G56, and so on and so on. And they will all have their own work shift, so they're all their own datum point. So with a settle point like this, if you wanted to run it overnight, all you have to do is call up those programs with the set offset.
And what does this give to a company that's got 3-axis machine tools? Is it all about flexibility?
Of course, it's all about flexibility. You can then move in to another part. You don't have to keep the cylindrical material on a lathe. You can move it onto a VMC like this. And basically, it's utilising and getting the best out of your machine.
Now the base, the micro-lock base, it's all gridded. You know, what benefits does this give you?
So the micro-lock is great because, like you said, it's gridded. You can space out each vise along the side. You can even machine your vise heads to your own components so they can sit in there nice and flush. Obviously, as well, as we can see, it's overhanging the table, but we've still got that reach. So you are using the table and more to be able to cut your material.
So they're maximising the machine strokes in this particular application. Are they doing anything wrong?
No, definitely not. And what they're doing is they're making, like we said again, they're making the most out of their VMC, and why not?
So before moving on, let's hear from Alan at Pinnacle Machine Tools, which ties in nicely with section 3.
Alan, in your opinion, how can we make machines like this more efficient? So talking about automation, anything like that?
Yeah, what we've got on this machine is we've actually got the Blum tool presetter. We've also got the component measurements on here as well.
Section 3, tool changing and tool setting. Paul, the problems in this area?
I mean, tooling is everything because, you know, you use lots of different tools for machining components. You need to make sure that they're set quickly. You can do it outside of the machine using a tool setting solution, or you can use, as we saw there, you know, the probing facility to be able to measure them. But if you don't practice those types of things, you could spend, you know, if you calculated it over a week, you could spend hours actually setting your tools and the spindle not going, which is something you really want to eliminate. It's not just that though, it's about thinking about how many tools you've got in your carousel, because the bigger the tool changer you've got, then the more flexibility you've got, and you might not have to stop the machine in order to put more tools in the carousel. That's important. You want to, and we come back to it, you want to keep that spindle running. So I think that the tooling side is really important, but it's not just also the tool carousel and the tools themselves. It's also about how quickly you can change from tool to tool. Now, some tool changers will have kind of sort of bi-directional or quick tool changing, so they'll position themselves ready for the next operation.
Yes.
So you haven't got to wait 15 seconds for a tool to go around a carousel. These are all things that you can look at when you're buying a machine. So really you need to be able to get that tool in and out of the machine as fast as possible. The changing of the tools, the chip to chip time will also have an impact, because if every time the tool is going out to put a new one in, again the spindle's not turning and the metal isn't cutting. So all of these aspects are key, but we'll hear more from Anthony Biggs actually from Fanuc about how impressive their robo drill is and how they save time with their tool changer.
Well, as we talked about, the Robodrill is an incredibly dynamic machine. So it's got a super fast tool changer. The movements around the machine are very quick, but there are still things we can do to be more efficient, to get those parts off quicker. So the control, for example, They're look ahead functions, they're smoothing functions, enable us to data the process in order to get the best machining condition, and just really maximise our efficiency.
Okay, so tell me more about the tool changer as well, because I can see it's not a conventional tool changer.
No.
It's not at the back of the machine, so that must save you time.
Yes, it's a mechanical design, and its beauty is its simplicity. Like lots of things Fanuc, it's incredibly easy to maintain, incredibly easy to repair, but it's built around efficiency. The tools are always available, and the numbers speak for themselves in terms of the tool-to-tool and the chip-to-chip times.
Yeah, definitely, I've heard.
Next up, section 4. How about adding an additional axis on the machine? Here's Paul and Joe in Technical Corner.
So Joe, we visit many engineering companies and they've got vertical machining centres with 4th and 5th axis units put onto them. What's the advantage to doing that, and where's the efficiency gains?
Well, I'll be controversial to start. A lot of people want this 5-axis machine, don't they? But quite often, a horizontal machining centre with like a trunnion system as a 4th axis, or even like you say, 5th axis bolt-on is the way to go.
You mean vertical?
Yeah, on the vertical. Sorry, on the vertical. So there's different advantages, but to me, you get more faces. You can get at 5 faces, and you can typically get more parts, presented to the spindle as well if you're using like a trunnion system.
But what you could do to achieve what you're saying as well is have multiple vices, where you could have Op1, Op2, Op3 and Op4, which would give you the same outcome as having a 4th axis unit though, wouldn't it?
No, because there are certain applications where if Op10, Op20 you can do 6 sides. Doing it with just a standard vice, you'd struggle. If you've got holes on the side, for instance, both sides and underneath, you couldn't do it. Whereas in some sort of trunnion system, you could, because you can, depending on how you load it, your Op10 and Op20, you would get it all 6 sides.
And also, it's important to stress that when you're doing it in this manner, you've got less chance of making a mistake, haven't you? Because you're not moving the part through the processes or through the different operations.
Yeah, the mind boggles, doesn't it, when we go to and we see various vertical machining centres, and there's one vice in the middle, and you've got a girl or a man loading that machine. It's just very, very inefficient. It shouldn't be done. Even at low volumes, it shouldn't be done. So yeah, whether you use 4th axis, 5th axis, a trunnion system, you need to do something.
And we're going to be showing a new feature shortly, a new product from Tame Workholding, which fits perfectly into this category. What about getting these units onto machines though? Is there any negatives to lifting on and off and interfacing and programming them, or is it all quite straightforward? Are you losing the gains by these things I'm talking about or not?
Well, inevitably you're going to lose, well, not always, but quite often you lose Z-axis travel. That's probably not a big issue to the majority of manufacturers out there. You can zero point now rotary tables and trunnions and 4th axis units. So you're probably going from a 30-minute setup down to a 2 or 3 minute setup now. So if 2 minutes is that important to you? Yes, but it's unlikely that it is.
And you can also set the 4th axis unit outside of the working area as well, couldn't you? Essentially, or the body of the 4th axis unit, which would mean you can maximise the stroke that you've got still within the machine. That's quite popular, maybe having a base plate on the table, which allows you to put it outside of that working area. So you're not losing your x-axis. That's going to be a gain.
Exactly, and to be honest with you, 9 times out of 10, it doesn't need to come off. The only time you need for it to come off is if you need that the extreme length of that machining envelope. But typically, how often does that happen? I'm not so sure.
And also a company we visited, Rigor Precision, they had a 4th axis unit with kind of like a tombstone in between centres with 4 sides to it with microlock workholding, which basically meant, or it was top and bottom, actually it was top and bottom, which basically meant they could index that through 180 degrees and present even more parts, as Gio says, to the spindle. That's taking it to the next level, isn't it?
Those parts will come off complete, probably, as long as there's no profile and things to do. That's as good as a 5-axis machine. I would say 90% of 5-axis work, you still need to machine the face you're holding. So it's still Op10, Op20 work anyway. So you may as well do it on a microlock type system, and there are others.
Because you could get 3 faces per side,
exactly,
which would be your six part, or your part finished with the 6 ops.
Yes, it's still 2 ops. You're just doing it on the VMC rather than a 5-axis machine. But that isn't done enough. To be honest with you, that isn't done enough.
Well, what about the 5th axis unit? Maybe let's look at this part here. Is this something that you might use or do or utilise a 5th axis table on a machine to do?
Yeah, you could. That would come off. Obviously there's no features here. So if it come from your material supplier like that, you could pretty much could come off complete, couldn't it? You may have to machine the part you're holding, depending on your drawings and things. But yeah, that would lend itself perfectly to a 5-axis positional part, wouldn't it?
Talking about the rigger precision, we actually calculated, working with him, that he was 50% more productive on those components. In fact, just over 50% more productive as a result of doing it in that method. So that shows a massive efficiency gain.
What would you do? What would you do? So if you're looking at, let's say you're not doing simultaneous work. The majority of the engineers watching this show won't be doing simultaneous work. Are they better off with a 5-axis machine, often presenting one machine part to a spindle, or are they better off with some sort of microlock or a trunnion system where they're getting it all 6-sided, albeit with 2 ops?
For the reasons that you say, if you had a 4th axis unit on the machine and you kept it as far out of the working envelope as you possibly could, so you're not losing your stroke, it also means you can leave it there, but it also means you can utilise the machine. Even if you are not wanting to use the 4th axis, you can still have multiple work holding solutions on the bed as well. So I think when it comes to flexibility, for me, it's definitely worth adding a 4th axis unit. I mean, they're not cheap, but they can make you more efficient. There are some lower cost versions, of which we're going to see a new product in a minute. But there are things like indexers as well. We talk about 4th axis, but an indexer which just moves to a position, doesn't it? And they've got like a button on some of these where you could bring a tool in, hit it, and it would index to the next position. Now, that's a pretty low cost way of doing more than one face, isn't it?
Yeah, I would argue if you can stretch yourself to get a proper rotary table or 4th axis unit, it integrates into a machine tool. I'd say that's always the way to go, but maybe it's a good start.
Good stuff. Okay, let's hear from Tame Workholding on this new product feature.
So yeah, David, how do we get more from a 3-axis vertical machining centre?
A whole new range of items here, Joe. As you can see, basic 0.3 axis round the top. Exactly the same with a vise.
So we're saying that's essentially the machine bed.
That's the machine bed. On top of the machine bed, a small 0-point plate. So we'll bring that over here for clarity. So yes, we can machine the part, but if we want to machine over, we need our multi-rise. Then you can machine in here through 90 degrees in here, so you can create all 4-axis stuff. The plate also rises, so if you have a large machine you want to get down, you have to use long tools. We're on really short tools, so that's it. And then, assuming this is your plate on your bed, we have
Multi-rad. Okay, so an indexing head basically.
It is an indexing head, but it's an inclining head really. And we use an inclinometer to get the angle, and we use our 0-point, our 4 studs. So we go from 0 to 90 and 90 to 180.
Okay, yeah.
And so on. So we move around to get all of the angles.
How often do you see a machine shop, 3-axis machine, with a part tilted over, there's some steel, it's been machined at an angle to get the compounds, isn't it? That's great if you've got a compound angle in any part. That's a good idea.
This saves you making dozens and dozens of fixtures just to stick a hole in the side or a slot or something like that. That's very simple. If you're trying to make something like this, make the combination. Got much comedy in this show? So
we've almost got manual 5 axes.
It's almost a manual 5 axes. So stick that in there. You can bring it round, do everything up of course, and then we can machine.
Fantastic, yeah. So there we are. So Tame Workholding, that's how you get more from your 3-axis machine.
That's it.
Next up, section 5, control systems and CAD CAM. Gio, Paul, the problems.
Well, you start.
Well,
Too polite.
I think that, with CAD CAM, I think it's something that's originated to make programming easier. and to save you actually programming on the duct board, and to program off the machine so you can keep that spindle turning. With a VMC, some of the parts that you could be making on there, but that's simple that you could just literally program on the VMC or on a laptop and send it to the VMC. For me, the main benefits, really, I know we're still talking about problems, but well, the problem is that the components have become far more complicated and complex than they've ever been before. So hence the fact that the programs will obviously be more complex. So that is a problem. So the solution is probably CAD CAM.
I also think though that it's about you point at a part on the table. It's about how you make that part as well, which is what good conversational systems can do, and CAD CAM. So it might tell you, or it might create machining paths that make the part slightly differently, slightly faster, which again then really improves your productivity. But it also might do things, it might help you with which tool it selects for which particular part of the application. So instead of having 10 tool changes, you might have 5. So there, once again, there's savings there. So it's taken the I suppose the intelligence in some instances away from the operator, and it's computing that in the control systems and the CAD CAM in order to make the part faster, do it in the most efficient manner, and really, reduce operations and all of that.
But just to add to that, because I think it's Mazak's digital twin, and they say that, you know, once they've attacked something in a certain way, it's artificially intelligent enough now to remember it. And so if you're then putting a new part on and it remembers that same process, it remembers it for the next time. So actually the machine is telling you the most efficient way of machining a part. And also, like with the Hercos as well, when we talk about that, the Hercos a lot, you're programming at the machine, and I hear so many good reviews about their CAD CAM system and how conversational and how easy it is as well.
It's optimization, isn't it, Lindsay? It's and artificial intelligence is going to play a big part in the future for sure, and it's simplifying the way in which you can program, which effectively saves time and makes you more efficient. And mentioning, like, going back to your technical corner, when you're adding more axis to a 3-axis machine tool, you're adding a 4th axis or maybe even a 5th axis, then again the operation becomes more complex to program, and that's where you'll get the biggest gains, in my opinion, from CAD CAM, because it's a more complex program. And with the CAD CAM, as you identified, Paul, it really will optimize that program and give you all the best data and cutting data to get the...
And one of the problems is, what used to happen a lot is people used to be programming at the machine while the machine's idle, and then they'd send the program down and they'd start machining. They'd finish the part. They couldn't program at the same time as the machine was cutting in years gone by, but they can do that now. So
that's what I was trying to say about the Herco.
They can be preparing for their next job, so that when that job's finished, the spindle stops, part comes out, next part comes in, call the new program up, and you're away. The next clip coming up is actually from C&F Precision. Mark here, they use Hypermill from Open Minds. They went away from vertical machining centres some years ago because of their inefficiency. Invested very heavily in Matsura's machines, and their efficiency now on those machines is sort of mid-90s, high 90%. But it's a different type of technology. But now they're looking at going back to vertical machining centres because they realise now they can make them more efficient than they used to by using some of the strategies that we're talking about in today's show. So let's hear from Mark. Mark, really interesting to be here at C&F Precision today. Looking at your 5-axis machines that you have here and the automation that you've got in the company, we're talking specifically about vertical machining centres and their efficiency this month on the show. Now, you did have VMCs before, but you would think about having them again, wouldn't you? And what are the reasons for that?
We find that by getting rid of the ones we had, we lost a little string to our bow maybe, but at the time it worked for us with the work we had. We're finding there's a lot of work that would actually suit a VMC, so it's definitely something we're going to look at doing perhaps later on this year.
And do you question the efficiency of those machines though? We've been talking back in the studio about 25-30% uptime on the spindles. If that's the case, how do you go about getting more out of machines like that?
I mean, it's to do with job selection to an extent. With the right work, I don't believe you'd lose that much spindle time. And then if we program the parts correctly, we obviously get good results that way as well.
Because you could add automation to them too as well.
You certainly can, yeah. You could automate it by putting a cobot or a robot in front of it, which is something we're also looking at doing potentially.
What about the CAD CAM side? That's the topic we've just been talking about in the studio. How impressed are you with Hypermill's software, or OpenMind's Hypermill software? What does it do for CNF precision, and how would it incorporate itself into efficiency gains on a VMC?
So the software is excellent. So with the right parts, you could program anything you wanted on OpenMind, and you get good versatility within certain tool paths. So you can go from standard roughing cycles to trapezoidal roughing cycles if the right part is on the machine.
So do you think that you could make productivity gains using CAD CAM on a vertical machining centre?
I think you could. With the right parts, if it's larger area parts that don't perhaps fit onto one of the machines we currently have, I definitely think there is scope there for us to utilise one of those machines.
So the penultimate subject, and section 6, is swarf. Now this can be a productivity killer along with coolant control. So Paul, let's start telling me where the problems are, but also what can happen if preventatives are not used to control swarf.
Swarf's massive, isn't it? You know, if you've got a machine where you've got sometimes I look at people buying vertical machining centres without swarf conveyors, and you see it and you just think, what, you know, okay, I know space could possibly be an issue, but you've got machines where swarf conveyors come out of the back, so they don't necessarily have to come out of the left, or they can come out of the left or the right. But how many times have I seen a guy in a machine digging out swarf, and you just think that is such a waste of time? So to avoid that is critical. The coolant side of things as well, you know, you can make so many efficiency gains. You can make your cutting tools last longer by using the right coolants. The recycling of coolants, the coolants that you use, you know, can be better than other coolants, which means you get you know, better efficiency from your machine. But you talked about through spindle coolant. Well, you were going to mention something about that, weren't you?
Yeah, you get up to 80 bar through spindle coolant, which I think is massive as well. You know, because if you're doing a deep bore, for example, you're getting that coolant right at the point of cutting, and obviously that gives you better feeds and speeds, better tool life longevity, and better tool life longevity across all machining operations if you've got the right coolant for the application, and it's absolutely critical. Clearing the swarf also has a good impact on the coolant as well, because you can go in and look at some of the coolant tanks on some of these VMCs. They're so dirty, and they're not cleaned. Filtering the coolant, you know, say if you're doing cast iron, you can get magnetic filters that can take the cast iron out of the coolant. And again, cast iron, although you can't see it in the coolant, but once it's in that system, it will erode the cutting tools. And swarf build up in the machine tool, not just in the machine tool, but say for example, if you're using 1960 technology workholding products where the swarf can get into the lead screw, for example, how many times do you see it that they've just finished one part, then they've got to get the arrows out and blow out all the swarf? Not only is that taking time, but that's a bit of an health and safety hazard as well, because the swarf's flying everywhere.
It's the reliability of the machine as well. If some of these factors you're talking about from a preventative maintenance perspective aren't utilised, then machines can break down. Machines can become inaccurate, which again affects the efficiency. If the machine's broken down for whatever reason, you can't use it, so the spindle's not going to turn. You can use air blasts and things to clear swarf out of the machining area, which is quite important as well, because and they get, you know, you get these trapping points in machines where you get this swarf build up by having coolant flood wash around the back too. Can get swarf into the conveyor and out of the machine. There's lots of things you can do in this area. Other than just going in with a hoover to hoover it out.
Yes.
A lot of people do it. They do
Paul,
do
when
it.
we were at R&G Precision the other day, we saw those robo drills, and I'm not kidding you. I've not seen it before. I've not noticed really, but I've never seen how small the swarf. Like the swarf was literally coming out the back and didn't even take up barely any room.
Yeah.
Just a tiny footprint of a machine, and then this tiny swarf conveyor, and you could see it was just so simple. Away from the machine. Get rid of the
slants on the bottom of the machine, the way that the swarf when it hits the machine are important points to consider when you're looking at a machine, because If it's got a gradient, it will fall away, it will fall into the conveyor, it will be moved out the back, using the wash
Really
facilities.
simple.
All of these things are important, because spending 10, 15 minutes, half an hour a day, an hour a day in a machine getting rid of swarf,
It's not efficient.
It's 100%. And another really big point, I know it's moving on a little bit into one of our future segments, but you know, if you're looking to automate that machine and run it 24/7, you need to make sure that you're getting rid of that swarf overnight, or that's going to cause you massive problems. But also, again, like we mentioned, with tool life longevity, if you've got a small tooling carousel, you can't afford to have twin doubled up tooling in there. And again, so it's absolutely imperative. You know, we're looking at efficiency gains on a VMC, and probably one of them is not running it, you know, into a second shift.
How would this work? Just a random idea.
Here we go.
If you had a massive suction thing in the machine that just rips out all the swarf, so you don't need a conveyor.
Suction or magnetic, or
well, a bit of both. Well, it'd be suction. You'd need to really pull it, but as it's cutting at the spindle, like a massive Hoover that just pulls all of
patent
the swarf
it, Paul. Patent it.
Good
we'll
idea.
see. We'll let you. We'll leave you with that
there's
one.
never any swarf in the machine, but you don't need a conveyor either, which takes up space.
And then where does it go? There you go. Right, or as always, remember to tell us the technology that you've used to help you get your spindle uptime. Comment on any of our channels. Now, coming up, that all-important result to our survey on what you think the efficiency of an average vertical machining centre is. So we've got 32%, 42%, 52%, or 62%. We'll also finish the show with some interesting statistics on what we believe the answer is following extensive research. But more importantly, we conclude by telling you how you can actually measure it. Right, the last topic is automation, possibly the biggest one. Where do we even start with this? And I suppose I would probably ask the first question to you, Paul.
Oh, can I not throw it to him?
You can.
No. The problems here is the first thing to talk about. And the problems are, again, we keep saying it, when the spindle's not being utilised or being used. That's where your efficiency goes out the window, when that spindle's stopped. By automating the machine, you are going to eradicate that from happening. You're also going to mean that operators can go and do other things in the machine shop. So really, the automation is becoming so crucial to making a VMC more efficient. Be interesting to see what the results of the survey are, which we'll talk about shortly, because I've got a prediction that I think people will be very, very wrong, because I think the efficiency of these machines isn't what people think. There are many solutions, and I know Gio is going to mention a few as well, and he'll probably talk about some of the ones I mentioned here, but you can use cobots that you can, you know, manually kind of move to show them what the path is to load parts and take parts out of the machines. You can use palletization systems, pallets that you can attach to a vertical machining centre, like you know, the Mayland system or a Midico system that can keep pallets moving in and out. There are sort of like the XYZ systems, where the Robo 10, where you actually can move it from one machine to another, and you've got drawers that you fill up. Mill CNC do one as well. Fanuc do them too. And in fact, Herco do one as well. So there's plenty of these pallet systems that will enable you, and they're very, very easy to program. They've developed their control systems, so even a person with the most limited experience on a machine can work these things.
They've merged them together. They want to, at the end of the day, they want to sell a vertical machine centre, and they've got something else to sell that works with it. So they're going to make it as in simpatico together as possible.
In simpatico.
Together.
And by the way,
I'll get some people on the thesaurus and the dictionary going, to make sense, that doesn't.
Lovely word.
There's two words. It's two words.
Lovely words.
In simpatico. Go on, carry on.
I'm going to give Dyson a call, actually. I love your invention. I think that's got legs. In regards to solutions, Paul, blimey, there's so many. I think that how many shops I've visited over the years where the last machine to be automated would be a three-axis VMC. Very rare I see a three-axis VMC automated. And if you can automate it, whether you're doing low volume work or high volume work like we've mentioned, imagine the instantaneous productivity gains that you would get from that. In regards to the work holding there, if you're doing high volume work and you're making the same part on a VMC every day, you can get hydraulic or pneumatic work holding solutions. So the robot can put the part in, the work holding opens, close, it communicates with the control system. Or if you're doing different work all the time, palletisation, as you mentioned, is absolutely perfect. But I think automation is one of the biggest aspects of all of this. It's the cream of the creme to get that efficiency.
Cream of the creme, isn't it? Cream of the crop.
And this is where there's...
Is it cream of the crop?
I thought so.
There's two ways of looking
Creme
at
de la
this.
creme.
Creme de la creme, that's the one.
There's buying a machine that already has automation fully integrated into it. And we don't want to move into 5-axis because that's not what we're talking about today, or adding automation to a machine. I interestingly went to a tool maker who has just bought an Aroa system to go with a Quasar vertical machining centre.
Yeah.
And he's a tool maker, you know. Now he's doing that because he wants to make sure that his spindle on his VMC is running for as long as it possibly can. And he's going to be loading sort of bolsters, big tools onto the Aroa system, pulling one out and putting another one in. So he hasn't got to, you know, you imagine doing that with a crane. You've got to open the doors, you've got to get crane in, crane out. So all that work's been done outside of the machine. So there are so many options with automation to be added to the machine, and they will, you know, unequivocally improve your efficiency.
I think I need to lie down now. I think I need to lie down.
Unequivocally, that's a beautiful one.
Instantaneous. That is emphatic. I mean, what have we done? Swallowed a dictionary.
One example, though, and I've got to use this example. I think we were talking earlier before the show. There's a company that's got 21 VMCs, and they're using one particular work holding solution per VMC. And they believe that everything they're doing is absolutely perfectly correct. But just imagine if they incorporate some of the solutions that we've discussed today. Potentially they could be doing all of their work on 4 or 5 VMCs. And that is as crazy as it's not crazy actually, it's reality. You know, some of these solutions that we're discussing can make a massive impact.
Yeah. So to conclude, there are so many areas you can up your productivity. Paul and Gio, the results of our survey, the answer is 62% is what people in the majority have selected. Do you think that?
Definitely not.
Nowhere. No way. I wouldn't have even, I know we've had this conversation before. Even before this program and doing all this research, it's probably under 32. I wouldn't even suggest it's 32.
You know what? I've been out to machine shops, and there's so many machines that just sit there idle, and you just think, what's the point? Like, I don't quite understand why you'd have a machine there. You must have thought and invested and put your business plan around that investment, and then for it to sit idle.
There'll be one machine running out and 3 idle. What's the point in having those other three? Just have 2. And maybe one, and make that one more efficient.
Definitely. Right, before we wrap this up, guys, how do you monitor efficiency? How can engineers watching this establish if they're efficient or not, Paul? Like, what's the answer?
Well, I'm going to talk about a particular product here called Factory Whiz. Now, this is one. There are a few products that are available in the market that are supplied either by the equipment manufacturer that work integrated into their machines, but there are ones that you can use like Factory Whiz, which you can connect up to all of the machines in your machine shop. Now this is where it will be a real eye-opener, and the piece we're going to cut to in a minute is a company that has invested in Factory Whiz, and they've actually identified that their VMCs were around about 40% efficient, I believe. That sort of
They
number.
said that to us.
That's not bad. You know, it's not bad, but they're aiming to get that to 60. And what something like Factory Whiz does, connected to all of your machines, whether it be a lathe or a VMC, it will tell you when the tool isn't in cut. Not only not when it's in cut, also the reasons why it's not in cut. Tool breakage, guy in the machine clearing swarf out, like we've said, tool setting, you know, whatever these things that we've mentioned in today's show, something like Factory Whiz will identify where those areas are.
If you can't measure it, you can't make improvements.
How can you solve it? Exactly. So, but this is a really interesting feature. So let's hear from Future Design.
Efficiency is a good area to jump onto then. What is it that you do in your machine shop that you would say that makes it efficient?
We obviously use Factory Whiz software that monitors the machines and also the way we go around jobs. We're running probably 40-45% efficient. We want to get up to around the 60-65% over the next couple of months. Up to maybe a year ago, we were holding jobs in old-fashioned vices that take up a lot of bed space, whereas now we're moving towards smaller vices that we can get multiple jobs on the beds, which again will make our efficiencies better.
Thanks for watching this month's Swarf and Chips special. Now keep an eye out on the website for the up and coming special features, and as always, keep tuned to our weekly show as we carry on the fight of promoting productive precision machining here in the UK with our 10-minute topic. We will be seeing you next week, and I hope you still make a comment on how interesting Paul Jones's socks were this week.